In this video, I want to cover a few example ACT problems that involve exponents. So the first one says, which of the following expressions is equivalent to the quantity 3 plus x raised to the negative 100 power? Now there's something you need to know when you have negative exponents. If I had x to negative 2 power, we don't like negative exponents. We want to keep it as a positive exponent. So what we do here, it moves to the bottom of the fraction as a positive exponent. So x to the negative 2 power is the same as 1 over x raised to the second power. If we had a negative start out on the bottom, it would just move to the top and be a positive exponent. So 1 over x to the negative 2 power is equal to x to the second power. So in this one we have a negative exponent. We got 3 plus x raised to negative 100. So following the rule, we want a positive exponent, so this can move down to the denominator. That's 3 plus x raised to the positive 100 power. And our answer choice would be E. So this next one says, what value of x makes the equation below true? So anytime you see exponents, you usually want to get all these into the same base. On the bottom we get 5 to the second power, and then 5 to the fourth power, and then on top 25 to the x power. So we want to put the 25 to the x power in terms of 5. So 25 is 5 squared. So 5 squared to the x power, or 5 to the second power, equals 5 to the fourth power. Now using a rule of exponents, if you have 5 to the second power raised to the x power, you can multiply those exponents together. So it becomes 5 to the 2x power divided by 5 to the second power equals 5 to the fourth power. And when we're dividing numbers that have exponents and they're the same base 5, we can subtract the exponents. So this becomes 5 raised to the 2x minus 2, and equals 5 to the fourth power. Alright, so now we have that. We have both sides 5 raised to something. In order for this to be true, the exponents need to be equal to each other. So we just set up a little equation, 2x minus 2 equals 4. Add 2 to both sides. And you get 2x equals 6. Divide both sides by 2. And then x equals 3. And you can verify your answer by plugging in your value for x. So 25 to the third power divided by 5 to the second power should give you the same as 5 to the fourth power. So this one says, which real value satisfies 2 to the x power times 4 equals 8 to the third power? So again, we want to write this in terms of the same base. So we can use 2. So 2 to the x power. 4 is really 2 to the second power. 8 can be rewritten as 2 to the third power. And then still raised to the third power. And we can multiply the exponents together, 3 times 3. So this is really 2 to the ninth power. Over here we get 2 to the x power times 2 to the second power. And when you're multiplying these together, you can add the exponents. As long as they have the same base, 2 raised to something, you can add the exponents together. So this becomes 2 raised to the x plus 2 power. And again, if we have the same number raised to some exponent, so 2 raised to the x plus 2 and 2 raised to the ninth power, these are equal. We can set the exponents equal to each other. So we have x plus 2 equals 9. I can subtract 2 from both sides. And x is equal to 7. This one says, which of the following expressions is equivalent to the quantity negative 2, x to the fifth, y to the second, all raised to the fourth power. So again, when we saw we're raising to the fourth power, we're going to change the exponent on all the inside ones by multiplying the exponent by 4. So we'll have negative 2 raised to the fourth power, x, we do 5 times 4 to give us 20. For the y, 2 times 4, they give us 8. I can evaluate negative 2 to the fourth power. That's going to give us 16. So 16, x to the 20 power, y to the 8th power. So our answer would be letter E. All right, so this one says, given that 10 raised to the 2x minus 1 divided by x power is equal to 1, x is equal to what? Now another rule with exponents, if you have anything raised to the 0 power, it's going to be 1. So if I had 2 raised to the 0 power, that's going to be 1. If I had 100 raised to the 0 power, it's also going to be 1. So anything raised to the 0 power is going to be 1. So we see here the exponent part of it, 2x minus 1 over x, has to be equal to 0 in order for this to equal 1. So we simply have 2x minus 1 over x. That has to equal 0. And if this is equal to 0, the top part of it needs to be 0. And then we need to verify that the bottom is not 0 because we can't divide by 0. So I'm going to add 1 to both sides. Give me 2x equals 1. And then divide both sides by 2. X equals 1/2. So x equals 1/2 works in this problem. It doesn't cause a division by 0. It just makes the top 0, giving us 10 to the 0 power, which will give us 1. So x equals 1/2. Choice C.